Hello everyone, my name is Anand Suthar and welcome back to my LeetCode Problem solving series. Today we are solving the longest repeating character replacement, LeetCode Problem number 424. This is the popular sliding window problem asked at Google, Amazon and Meta. It's built directly on the concept we learned in LeetCode Problem number 3. Let me show you how to solve it. Here is the problem. We are given a string of uppercase letters and integers k. We can change any character to any other uppercase letters. We can do this at most k times. We need to find the length of the longest substring that contains the same letters after the most k replacement. Let me show you example. In example 1, we have given a string s, ab, ab and k is 2. We can replace the 2 a's with b's to get 4 b's, length 4, or replace the 2 b's with the a's to get the 4 a's. Also the length 4 and its output is 4. Similarly in example 2, the brutal force approach would check the every substring. It's too slow. We need the efficient solution sliding window approach. Here is the key insert. In any valid window, the numbers of characters that needed to be replaced equals to window's length minus the frequency of the most common character in that window. Think about it. If the window has 5 characters and the most frequent letter is 3 times, we need to change the other 2 characters that the 5 minus 3. For the window to be valid, this number must be less than or equal to the k. So we maintain the window. As we expand it to the right, we check is window size minus max frequency is less than or equal to k. If yes, great, our window is valid. If no, we need to shrink the window from the left until it's become valid again. We keep track on the maximum window size we have seen. Let me write the code. We start inside our public function character replacement. First we build the square boards, a vector called frequency of a size 26 initialized with 0. This will keep the count of how many times each character appear. Next we initialize the 3 integers. Left is set to the 0 to mark the starting left edges of our sliding window. Max frequency track the count of the single most popular characters inside the current window. Finally max length is the record keeper, which will hold the maximum valid substrings length we find. We jump to our for loop using the variable right to scratch the right edges of our window forward across the strings, one character at a time. As the right boundary shallows new characters, we update our square boards. By subtracting the characters a from the current character s right, we convert the letter into the safe array, then we increment its frequency count. Right after updating the counts, we refresh the max frequency. We compare the previous highest frequency against the updated count of frequency characters. We just show making sure the max frequency always holds the current popular records. Now comes to the core logic. How do we know if the current window is valid? Think about it. The size of a window is the right minus left plus 1. If we take the total size and subtract the count of the most popular length, max length, the remaining number tells us exactly how many other letters we do need to replace. If that counter is greater than k, our window is invalid because we do not have enough operations left to fix it. If that valid check fails, we have the shrink window. From the left side to fix it, we look at the character settings. The left pointer decrements its current the square boards using the frequency s left minus a minus minus, and then slide the left pointer forward by doing left plus plus. Once the window is verified to be valid, we calculate the current width using the right minus left plus 1. We compare it against our records holders max length and save the largest value. The loop keeps sliding until the right boundary hits the end of the strings. Finally, we return the max length as the winning answer. Because our right boundary moves across the string exactly once and the other alphabet takes constant space, our time complexity is optional on and the space complexity is flat constant. Let me submit this. It passes. That is longest repeating character replacement using a sliding window. Key points to remember. Window valid when size minus max frequency is less than equal to k. Tracks max frequency in current window. Shrink window when it's valid. Keep the track on the maximum valid window size. If this helped you, please like and subscribe. I'm Anand. Thanks for watching. I'll see you in the next problem.